I'm working with a dataset containing 100 samples, each described by 5 features. The goal is to predict 3 different target variables for each sample. This is a multi-output regression problem because I want to predict multiple things from a single input. Think of it like predicting a house's price, size, and age based on its features. These are the settings I can adjust in my MultiTaskElasticNet model to control its behavior. In this case, I'm focusing on ALPHA and think of them as knobs that fine-tune the model's learning process. This hyperparameter controls the strength of regularization in the MultiTaskElasticNet model. A larger ALPHA value means stronger regularization. It's like a penalty for complex models. I'll explain more about regularization later. This hyperparameter balances 2 types of regularization, L1 and L2. L1 is like picking the most important features, sparsity, while L2 tries to make the model more general, reducing overfitting. Determines how much of each regularization I want to use. If it's 0, I'm only using L2. If it's 1, I'm using only L1. Think of it as a slider to mix these 2 types of regularization. This is a technique I'm using to evaluate the performance of the MultiTaskElasticNet model with different hyperparameter settings before using them on my entire dataset. It helps me to avoid overfitting and get a better estimate of how well my model will perform on new, unseen data. I'm essentially training and testing it multiple times with different subsets of my data. I have a dataset with 100 different observations. Each observation is represented by 5 independent measurements, or features. And for each of these observations, I'm trying to predict 3 different continuous values, or target variables. I'm using the MultiTaskElasticNet algorithm from Sklearn to solve my multi-output regression problem. The goal is to find the best settings, hyperparameters, for this model. Tuning means trying out many different combinations of hyperparameters to see which performs best. This is a specific type of regression model from the Sklearn library in Python, designed to handle problems where you have multiple target variables that are possibly related to each other. It uses a technique called elastic net regularization, which is a combination of L1 and L2 regularization techniques. We're tuning the settings, hyperparameters, of a Sklearn model called MultiTaskElasticNet. This model is designed for situations where you're predicting multiple things at once, in this case, 3 target variables. Think of it like trying to predict the height, weight, and age of a person all from the same data. We'll adjust settings called alpha and L1 ratio to find the model's best performance. The L1 ratio setting controls a mix between 2 types of regularization, L1, lasso, and L2, ridge. Think of regularization as adding constraints to keep the model from getting too complex and potentially overfitting the data. A value of 0 means I'm using only L2 regularization. A value of 1 means I'm using only L1 regularization. Values in between give me a blend of both. This statement is incorrect. Actually, MultiTaskElasticNet does not assume the target variables are independent. It's designed to handle situations where they are related. The model cleverly uses shared regularization to consider connections between the things I'm trying to predict. Setting alpha to 0 means there's no regularization at all. This will let the model become overly complex and potentially lead to poor performance on new data because it will have memorized the training data too well. This quiz focuses on understanding how the hyperparameters, alpha and L1 ratio, affect the Sklearn's MultiTaskElasticNet model. We'll explore how these settings influence model behavior. Let's dive in. These are the settings that we can tweak in the MultiTaskElasticNet model. We have 2 here, alpha and L1 ratio. Think of them as knobs that control the model's behavior. This is a regularization strength parameter. Increasing alpha increases the penalty for large coefficients, leading to a simpler model and potentially reducing overfitting. I'll explain this in detail later in the quiz. This controls the balance between L1, lasso, and L2, ridge, regularization. A value of 0 is pure L2, while 1 is pure L1. L1 regularization tends to make some coefficients exactly 0, which helps in feature selection. L2 regularization shrinks the coefficients but doesn't force them to 0. We're working with a dataset containing 100 samples, each described by 5 features, and we aim to predict 3 different target variables. This is a multi-output regression problem, suitable for MultiTaskElasticNet. These are the statements about the behavior of MultiTaskElasticNet and its hyperparameters that we need to analyze and determine whether they're true or false. This quiz focuses on understanding how we can adjust the settings, hyperparameters, of a specific machine learning model called MultiTaskElasticNet to get the best performance. It's like fine-tuning a recipe. We adjust the ingredients, hyperparameters, to get the perfect dish model. We are using MultiTaskElasticNet model. This is a type of model that's especially good when you want to predict multiple things at once. Think of it as a multitasking machine. These are settings that control how the MultiTaskElasticNet model learns. 2 key ones are alpha and L1 ratio. Think of them as the knobs and dials I can adjust. Alpha controls the strength of regularization. Regularization helps prevent the model from overfitting to the training data, ensuring it generalizes well to new data. A higher alpha means stronger regularization. It's like adding a bit of salt to a recipe to enhance the flavor while preventing it from being too intense. L1 ratio determines the balance between 2 types of regularization: L1, lasso, and L2, ridge. A value of 0 uses only L2. A value of 1 uses only L1. They are different techniques to prevent overfitting. It is like balancing 2 types of spice in a recipe. I'm working with a dataset containing 100 examples, each described by 5 characteristics, features, and trying to predict 3 different things, target variables, for each example. Think of it as 100 recipes, each with 5 ingredients, and I'm trying to predict 3 different aspects of the finished dish, like taste, texture, and appearance. To find the best values for alpha and L1 ratio, I'll use cross-validation. This is a technique to evaluate the model's performance fairly. It helps to prevent overfitting to specific training data. The quiz presents me with statements about the model's behavior and the effect of the hyperparameters. I need to determine which statements are true based on my understanding of the MultiTaskElasticNet model. It's like analyzing the results of multiple cooking experiments to determine the best recipe settings. Increasing alpha increases bias, makes the model simpler, potentially missing some details, but decreases variance, makes the model more consistent in its predictions. L1 ratio controls the mix of L1, lasso, and L2, ridge, regularization. 0 is pure L2, 1 is pure L1. MultiTaskElasticNet does not assume the target variables are independent, it considers relationships between them. Setting alpha to 0 turns off regularization, which can lead to overfitting. I'm using Sklearn's MultiTaskElasticNet, a tool that's great for handling regression problems where you have multiple things you're trying to predict at once. Think of it as a supercharged regression model designed for situations with multiple target variables. This is a hyperparameter that controls the strength of the regularization. It's like a dial that you adjust to fine-tune the model's complexity. A larger alpha means stronger regularization. This hyperparameter determines the balance between 2 types of regularization: L1, lasso, and L2, ridge. Imagine it as a mixing knob. At one extreme, L1 ratio equals 0. You have pure L2 regularization. At the other, L1 ratio equals 1. You have pure L1 regularization. And in between, you have a mix of both. I'm working with a dataset that has 100 data points, samples, each described by 5 features, input variables. The goal is to predict 3 different things simultaneously, target variables. I'm using cross-validation, a clever technique for evaluating my model's performance. This ensures that I get a reliable assessment of its generalization capability by testing on multiple subsets of my data. I'm preventing overfitting by seeing how well my model does on data it hasn't seen during training. I'm tuning the hyperparameters, ALPHA and, of a scikit-learn model called MultiTaskElasticNet. This model is designed for regression problems with multiple target variables. I'm working with a dataset containing 100 samples, each described by 5 features. Importantly, each sample has 3 associated target variables. That means I'm trying to predict 3 different things for each sample. This is just a more detailed description of the dataset, confirming the scale of the problem. I have a relatively small dataset, but it's multi-target regression, adding complexity. I selected MultiTaskElasticNet because it's specifically built to handle multiple target variables simultaneously. This is different from having separate models for each target because MultiTaskElasticNet considers relationships between them. These are settings that I can adjust to control how the model learns. I'm focusing on ALPHA and because they directly influence the model's behavior and how it balances simplicity and accuracy. This is a regularization strength parameter. Larger values mean stronger regularization. This helps prevent overfitting by penalizing large model coefficients. This controls the balance between L1, lasso, and L2, ridge, regularization. A value of 0 is pure L2, 1 is pure L1, and values in between are a mix. L1 regularization helps to produce sparse solutions, with some coefficients exactly 0, while L2 produces more dense solutions, small but non-zero coefficients. I'm using cross-validation to get a more reliable estimate of my model's performance. Cross-validation helps me to avoid overfitting to the training data, and it gives me better generalization to unseen data. After tuning, I'll evaluate the model's performance using appropriate metrics for regression. These metrics may include mean squared error, MSE, R-squared, mean absolute error, MAE, etc. The results will tell me how well the model predicts the target variables. I'll use these results to choose the best hyperparameter settings and gauge the model's overall effectiveness. We're tuning the MultiTaskElasticNet model, which is a scikit-learn tool. This means I'm going to adjust its settings, specifically ALPHA and, to find the best performance. Think of it like fine-tuning a machine. I'll use a dataset with 100 different examples, each described by 5 characteristics or features, and with 3 outcomes or target variables I'm trying to predict. This is a typical multi-output regression problem. It's like having 100 houses and measuring 5 aspects, square footage, location, etc., to predict 3 different things: rent, sale price, and property taxes. I'm asking if some statements about the MultiTaskElasticNet model and its settings, ALPHA and, are correct. This is a multiple-choice question to test your understanding. The MultiTaskElasticNet model is a specific type of regression model that's perfect for datasets with multiple outcome variables. It uses a combination of L1 and L2 regularization to prevent overfitting. It's designed to handle situations where the outputs are possibly related, unlike a simple linear model for each output variable. These are the adjustable settings that control how the MultiTaskElasticNet model behaves. ALPHA controls the amount of regularization, how much I penalize large parameter values, while determines the balance between the L1 and L2 types of regularization.